You must have seen the food packets on which the composition is printed, especially the amount of acidic or basic substance that is obtained by reacting it against a solution of known strength. Do you know that the above procedure is called titration? Let us find it out through the video. We will study the acid-base titration method to calculate the concentration of an acid or a base by reacting it with a solution of a known concentration using a suitable indicator. Let's observe a bowl of milk which has been left on the table for the past one day. What has happened to it? It has curdled and turned sour. Put a few drops of a universal indicator solution into the bowl of fresh milk as well as the curdled one. We see that the red color produced in the curdled milk is brighter. This shows that the curdled milk is more acidic than the fresh one. But how much more acidic is the curdled milk than the fresh one? The answer to this question can be found out by reacting known volumes of both the samples with a suitable base in the presence of an indicator. This process is called an acid-base titration. To understand the principle behind titration, let's consider a reaction between hydrochloric acid and a 1 molar sodium hydroxide solution. Here, the sodium hydroxide solution, whose concentration is known, is called a standard solution. Take 10 milliliter of this standard solution in an Erlenmeyer flask. A burette, which is a long graduated tube with a capacity of 100 milliliters and a stopper at the bottom, is filled with the HCl solution. Before starting the procedure, 2 to 3 drops of an indicator such as phenolphthalein are added to the solution in the flask. Phenolphthalein turns pink in a basic solution like that of NaOH. Hence, the color of the solution in the conical flask turns pink. As soon as we start adding HCl from the burette into the NaOH solution, the chemical reaction starts. During this reaction, the acid and the base molecules react to form a salt such as sodium chloride along with water. On an ionic level, H plus ion from the acid react with OH minus ions of the base to form molecules of water. This reaction is called neutralization. The conical flask is agitated continuously to ensure a proper mixing of the two solutions. As acid gets added to the NaOH solution, more and more salt and water are formed. The concentration of the NaOH goes on decreasing due to its neutralization by HCl. When all the NaOH reacts with the HCl, we get a neutral solution in the Erlenmeyer flask, and the solution thus turns colorless. This is called the equivalence point of the reaction. At this stage, the number of equivalents of HCl and NaOH, which have reacted with each other, is equal. The reading on the burette is used to calculate the number of equivalents of HCl. We can see that 20 ml of hydrochloric acid solution of an unknown concentration has reacted completely with 10 milliliter of a 1 molar NaOH solution. It is clear from the chemical equation that 1 mole of NaOH reacts completely with 1 mole of HCl. The number of moles of HCl in a given solution is given by M multiplied by V. where m is the molarity of HCl in mole per liter and V is the volume of the solution in liters. Thus, from the chemical equation, m times V of HCl is equal to m times V of NaOH. This equation is often referred to as the law of molarities. Substituting the values of the known parameters in the above equation, we get m times 20 upon 1000 is equal to 1 times 10 upon 1000. Thus, molarity of HCl is equal to 1 times 10 upon 20, which is equal to 0.5 molar. If instead of HCl, a sample of sulfuric acid is titrated against sodium hydroxide, the chemical reaction taking place in the flask will be different. Here, sodium hydroxide gets neutralized by sulfuric acid and sodium sulfate is formed along with water. 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide to form 1 mole of sodium sulfate and 2 moles of water. Thus, the ratio of the number of moles of H2SO4 and NaOH which react completely with each other is 1:2. In other words, m times V of H2SO4 is equal to 2 times the product of m and V of NaOH. Therefore, molarity of H2SO4 is equal to 2 times the product of molarity of NaOH and volume of NaOH divided by volume of H2SO4. Hence, the concentration of an acid or a base can be found out using the titration method. Note here that as the calculations of the concentrations of the solution involve the volumes of the reacting solutions, this process is often called the volumetric analysis. To summarize, using the acid-base titration method, we can calculate the concentration of an acid or a base by reacting it with a solution of a known concentration, using a suitable indicator and the following formula. As the calculations of the concentrations of the solution involve the volumes of the reacting solutions, this process is often called the volumetric analysis. You are advised to drink a solution of sodium hydrogen carbonate to relieve the distress due to acidity. What does the sodium carbonate do? Well, hydrogen from hydrochloric acid is displaced by sodium atom from sodium hydrogen carbonate, and overall it is a displacement reaction. Watch the next video to learn about displacement reactions.